A key concern around climate change is that an increase in extreme weather events may lead to conflict and instability in fragile parts of the world. Many African countries are believed to be especially vulnerable to this threat, and this paper studies one particular contributing factor: the prevalence of transhuman pastoralism. This is a form of animal husbandry that relies on the seasonal movement of grazing animals. In typical years, neighboring transhuman pastoral and sedentary agricultural groups coexist in a mutually beneficial relationship. In the wet season, farmers cultivate crops on productive land, while pastoralists graze their herds on the wild grasses of more marginal land. In the dry season, when this growth no longer occurs, they migrate to the farmlands that are left fallow after the final harvest. This arrangement provides pastoralists with dry season sustenance for their livestock, and farmers with a source of nitrogen-rich organic fertilizer. At the end of the dry season, the migration reverses, and pastoralists return to more marginal grazing land. Transhumance routes are an extensive feature of many parts of Africa, but the increased frequency of droughts in recent decades threatens their stability. Low precipitation may lead to insufficient plant biomass, or phytomass, on grazing lands, thereby inducing pastoralists to migrate before the final harvest. This can lead to tension and conflict as animals damage crops and pastoralists compete with farmers for water and pasture. This paper examines whether there is a systematic empirical relationship. Has climate change disrupted long-standing relationships between neighboring pastoral and agricultural groups? As a first step, the authors used geocoded conflict data from 1989 to 2019 to test whether violence is more prevalent in areas that border the territory of transhuman pastoralists. When looking across ethnic groups, they find that those who neighbor transhuman pastoralists are more likely to experience conflict. In fact, this relationship exists at the level of a 0.5-degree grid cell, which is around 55 kilometers square at the equator. Within the same ethnic group, cells whose nearest neighboring ethnic group is transhuman pastoral experience more conflict. So, the central question is whether these patterns reflect the impact of adverse climate events. The authors augment their data with measures of rainfall and find that lower precipitation in the nearest neighboring ethnic group increases conflict in a given cell, but only if that neighbor is transhuman pastoral. A 1 standard deviation adverse rainfall shock in a transhuman pastoral group increases the risk of conflict in a nearby grid cell by around 39%. For the same shock, a non-transhuman pastoral group has a statistically insignificant effect of only 2%. And while there are sizable spillover effects of having lower rainfall for neighboring transhuman pastoralists, there is no evidence that rainfall in a cell has a direct effect on conflict in the same cell. These findings are consistent with the idea that periods of low rainfall spark conflict by suppressing plant growth and inducing pastoralists to migrate early to nearby farmland. A series of falsification tests further support this. The estimated effects are driven by conflict in agricultural rather than non-agricultural territories. Similar results are obtained when rainfall is replaced with measures of phytomass growth, and the effects are concentrated in the wet season when crops are still being cultivated, rather than during the dry season when farmland is left fallow. Moreover, there are no spillover effects when looking at temperature shocks rather than rainfall shocks. This is an important check because, unlike rainfall, temperature is not a first-order determinant of phytomass growth in sub-Saharan Africa. And while existing research has established a link between temperature and conflict, those mechanisms cannot account for the spillovers observed here. These results accord with first-hand accounts of how climate change has disrupted the balance between transhuman pastoralists and farmers, and they shed light on a notable trend. Over the past 2 decades, there has been a dramatic increase in extremist religious conflict in Africa. And because transhuman pastoralists tend to be Muslim, while sedentary agriculturalists tend to be Christian, drought-induced conflicts between the two may spark religious violence. And in fact, estimates show that the mechanism highlighted here affects both jihadist and non-jihadist violence similarly, and suggest that if rainfall had been 1 standard deviation higher during the study period, jihadist conflict would be 31% lower. So, what can be done? The paper finds no evidence that development aid helps mitigate the effects of climate change on intergroup violence, but what does make a difference is political representation. Pastoralists are typically underrepresented in national politics, and this can increase the likelihood that state forces use violence to protect the property rights of landowning farmers. But when political power is more equitably distributed, the estimated spillover effects of rainfall on conflict are close to 0. This suggests that institutions that facilitate a balance between grazing and cultivating rights are crucial in mediating these climate-induced conflicts. To read more on this topic, you can check out the paper's references to other related work. This includes many papers on climate change and conflict, including those focused on intergroup relations and the role of migration.